Hi, Algebra 2, it's Mr. Szybisty again, and today we're going to talk about Unit A4, Absolute Value Inequalities. This is very similar to what we talked about last time with absolute value equations, but these are an example of what you're going to see. You're going to see an absolute value, and you're going to see an inequality sign. Now, what I want to remind you is that there are two different inequality signs that we have in math. One says greater than. So here with absolute value, what we're really saying is the distance is bigger than 5. So I'm going to write distance is bigger. And with this one, this is a less than symbol. So here, distance is smaller. The distance is smaller than 5. We have this thing to help us remember what we need to do when we encounter one of these signs. The cheer that we've got is called GO-LA. And it's a mnemonic device, meaning each of these letters stand for something that'll help us remember. The G stands for greater than. When we see a greater than, it will be an or inequality. When we see an L, a less than, we know it will be an and inequality. And during this video, we're going to go through 4 examples. 2 will be ors, and 2 will be ands. And as we go through the process, you'll see the difference of what an or looks like and what an and looks like. So let's get into our very first example, example 1. The absolute value 3x minus 2 is less than 5. So I already know that this is a less than, which means that this will be an and inequality. So how do I handle an and inequality? Well, if the distance is smaller, this part right here in the middle, the 3x minus 2, is going to be in between 5 and we add this part here, the negative possibility, negative 5. Now with an and inequality, when we go through and we do the math, it's almost like we have 2 equal signs. Whatever you do to the middle, you have to do not only to this side over here, this equal sign, but also to this side. For example, our next step would be to add 2. Well, if you add 2 to this side, you have to add 2 over here and over here. That keeps everything together. It keeps all the statements correct. Negative 5 plus 2 is negative 3, less than 3x, less than 7. And now we divide by 3, and divide by 3, and we get negative 1 is less than x is less than 7 over 3. So that's one of the ways that we'll write our answer. But just like in Unit A3, that there were 3 different ways that you could write your answer, the absolute value inequality also has 3 different ways. This is the first one. The second one is using squigglies in set notation. And this is the way that we're going to write this. Because we'll have this interval, we do the set of all x such that negative 1 is less than x is less than 7 over 3 squiggly brace. So that's our set notation on how we'll write the answer. The final way is using a number line. Here we have 0, negative 1, 2, 3, 1, 2, 3, 4, 5. So we have our number line. Now, I know I'm going to put a dot at negative 1. In absolute value equations, because they were equal, I put a solid dot. This one is not equal. It's strictly negative 1 is less than x. So instead of putting a solid dot at negative 1, I'm going to put an open circle. I'm also going to put one at 7 over 3. 7 over 3 is about 2.3, which means 7 over 3 is going to go between 2 and 3. So I'm going to put an open circle there at 7 over 3. With the inequality, there are a bunch of different answers that work. There are a bunch of different numbers that are bigger than negative 1, but are less than 7 over 3. It's the numbers in the middle. Notice here x is in between these 2 numbers, so I'm going to shade in between the 2 numbers. And so I have an inequality as an answer, set notation is an answer, and this, and they all mean the same thing. So that was example 1, which was an and inequality. Now let's see one that's an or in example 2. 2/3 x minus 5 over 2 is greater than 10. This is a greater than sign, which means I know this is going to be an or. The ors look just like absolute value equations. One is just like this without the absolute value. 2 over 3x minus 5 over 2 is greater than 10, or the negative possibility. Negative 2/3 x minus 5 over 2 is greater than 10. So those are our two different possibilities. Let's work with the one on the left and solve that. So the first thing I'm going to do is I'm going to add 5 over 2 to both sides. So 2 over 3x is greater than 25 over 2. Now again, I've got a fraction over here, so to get rid of the denominator, I'm going to multiply both sides by 3, the denominator. This cancels with the denominator. It leaves the numerator. 2x is greater than 75 over 2. And then finally, divide by 2, divide by 2. X is greater than, this is 75 over 4. So that's one of the possibilities. On the other side, the first thing I want to do is I want to distribute my negative sign. Negative 2/3 x plus 5 over 2 is greater than 10. And now, subtract 5 over 2. Negative 2/3 x is greater than 15 over 2. Again, I've got the 3. I want to get rid of it. It's in the denominator, so I'm going to multiply both sides by 3. The 3's cancel out. It leaves negative 2x is greater than 45 over 2. That's 42. 45 over 2. Last step, divide both sides by negative 2. Here's a very important comment that you've got to have down in your notes. Whenever you multiply or divide by a negative number, the inequality sign will flip. So these cancel. X, flip the inequality, and then this is negative 45 over 4. So one of the ways that I'm going to write my answer is x is greater than 75 over 4, or x is less than negative 45 over 4. So there's one way. The next way is using squiggly braces and set notation. The set of all x such that x is greater than 75 over 4, or x is less than negative 45 over 4. Close the squiggly braces. And finally, you might see this on a number line. Before I do this number line, I'm going to put 0 here in the middle. I need to know what the decimal approximations are for this. So 75 over 4 is 18.75, and negative 45 over 4 is negative 11.25. That's going to be a lot of tick marks if I actually go through and tick all the way up to 19 and all the way down to negative 12. So I'm going to take a little bit of a shortcut. Instead of going up by 1s, I'm going to go up by 5s. I'm just going to make a note of that down here, what each of these mean. And then to the left, negative 5, negative 10, negative 15. Now notice that there are no lines underneath the inequalities, so I'll be using open holes here. An open hole at negative 11.25, it's about right here. And an open hole at 18.75, that's about right here. Now in the and, the x was in between these two numbers and we shaded in the middle. That's not the case for an or, it's the opposite. X is greater than 75 over 4, greater than is this way, greater than that point, and less than negative 45 over 4. That's in this direction. So I shade over here. And that's example 2. Notice the 3 ways to write the answer in inequalities, set notation, and as a number line. So now we can get on to example number 3. We're dealing with a greater than, which means that just like in our last example, this is an or. So I know that I have this one, 2x minus 1 is greater than or equal to 3, or the negative possibility. On the right here, I'm going to add 1 to both sides. 2x is greater than or equal to 4. Divide both sides by 2. X is greater than or equal to 2. On the right side, after I distribute the negative, negative 2x plus 1 is greater than or equal to 3, minus 1 on both sides. Negative 2x is greater than or equal to 2. Then I divide both sides by negative 2. Remember, when you divide or multiply by a negative number, the inequality sign has to flip. So x is less than or equal to negative 1. So now I can draw my number line. Here's 0, 1, and 2. Here's 2. Here's negative 1. There's a line underneath. This means that it's equal to, and also the inequality. We're back to equal to, which means I'm going to use a solid dot. So a solid dot at negative 1 and at 2. And because this is an or, less than negative 1 is in this direction. Greater than 2 in this direction. That's one of the ways that we can write our answer. We might write it as x is greater than or equal to 2, or x is less than or equal to negative 1. The final way is in set notation, set of all x, such that x is greater than or equal to 2, or x is less than or equal to negative 1. Those are our 3 ways. Now it's time for example 4. This is a less than, which means that this is an and inequality. Which means the way that I rewrite this goes in the middle. That's on the outside this way, and then I have the negative possibility over there. Remember, absolute value will always have 2 possibilities, one positive, the other negative. So now I go through the algebra, add 3 to all 3 sides. Remember, with an and, you've got really 2 equal signs. Whatever you do in the middle, you have to do to the 2 outsides as well. So this is 10, 5x in the middle, and negative 7 plus 3 is negative 4. Now, whatever I do in the middle, I have to do to the outside. Divide everything by 5 so that these 5s will cancel out. Negative 4 over 5 is less than or equal to x, less than or equal to 2. That's one answer. I could do the set notation. That's not how we do the set notation. The set of all x such that x, oh, we'll give it one more try. We do the squiggly, the x, and then the line. This is x such that, and then we take the inequality and we put it in. Negative 4 over 5 is less than or equal to x, less than or equal to 2. By the way, this is set notation. You may also see it written as set builder notation. So if they ask you to write your answer in set builder notation, this is what they're looking for. Finally, we'll see this as a number line. So here's 0, here's negative 1, 1, and 2. Negative 4/5 is between 0 and 1. And I've got lines underneath my inequality, so I'm going to draw solid dots. And then a solid dot at 2. Now, because the x is in between negative 4/5 and 2, I'm going to shade in between negative 4/5 and 2. And so there we have our 3 different ways of writing our answer. We have our inequality, we have our set, also called set builder notation, and then we have our number line. So it's time for a U-try. And today's U-try is this absolute value inequality. The absolute value, 3x plus 2, is less than 5. Pause the video, give this one a try, and see if you can't get it right. All right, the answer that we're looking for, this is a less than, so I know that this will be an and. The interval, or the inequality, is this. Negative 7 over 3 is less than x, is less than 1. As a set, we use set builder notation. Again, it's a squiggly brace, x, a line. Sometimes we use a colon, 2 dots. And then the inequality, and then another squiggly brace to close it. And then if you were to draw this on a number line, you'd have 1, and negative 7 over 3 is in between negative 2 and negative 3. There are no lines underneath the inequality, so this is not an equal to. I'm going to use open circles. An open circle here, and an open circle here. And because it's an and, x is in between these two. I color in between. Make sure you ask a question or two if you are not able to get any of these 3 answers like we got them here. Great work today, Algebra 2. We'll see you next time where we'll be doing some absolute value graphing. What does this look like if you actually graphed it on a plane? Talk to you guys later.